Was that? Yeah. Like it's an amazing. If you can do it, you know.
Yeah, our AutoSE project.
I think the microphone's not working.
Application. Microphone. not working.
Okay. Yeah.
So can you guys hear me?
No.
Accelerated education. So.
Can you hear us?
I don't have like a few here, guys.
Can you hear Zixuan?
That's probably okay.
Let me get your.
He already texted you, it's in the closet. You never found it? It says in the closet. He texts you the group, the event group. It's right here. You never follow his instruction.
Yeah.
It's already charged. And I say it's like a, it's there. You say you went to my room and he said it's here.
She was kind of wanting this whole thing. So it's her.
Okay, so let's get started. My name is Stefan. So today I'm gonna talk about our AutoSE project, which is Agentic AI application workflow. So here's my agenda. So I want to go through the sections one by one. So I will first to do a self-introduction, and then after that I would like to talk about the rationale for building our AutoSE, like why we like to invest for our project. And then after that, I want to do a comparison between the GitHub Copilot as well as our AutoSE. Then after that, I would like to introduce our features as well as some other key highlights. Then last but not least, I would like to introduce understanding in the assembly based leaderboard. And then I will also do another comparison between the assembly agent as well as our AutoSE. So let's get started. My name is Sean, and I'm a software development engineer at Vedance, focusing on cloud AI infrastructure area. And I have been actively working in the design and development of cloud infrastructure system. And also, my recent work includes a service designed to enhance the resource management of cloud infrastructure, resulting in significant improvements in both resource efficiency as well as operational efficiency. And also, our team is dedicated to building cutting-edge AI infrastructure that powers innovative solutions across various domains. And also, we're also focusing on creating scalable, reliable, and also efficient systems that enable seamless integration of AI technologies into the existing workflows. Then you guys may be curious about like what is AutoSE? So AutoSE, which stands for Automated Software Engineering, which is the AI agent-based service that automates various software development activities. And also it is designed to seamlessly tackle the complicated software tasks across different stages of software development lifestyle, including the coding, design, and testing, as well as the operation. And also by leveraging the cutting-edge LLM and AI and the AI agent technology, our AutoSE aims to provide more effective solutions to these challenges. And also, other than that, I would like to mention that we are integrated with the fourth branch of SW agent. So since our AutoSE is an agentic AI application workflow support system, actions plays a really important role in our project. And also, we have already made several enhancements to the SW agent by adding a lot of different actions. And other than that, I would like to state that we're still in the process of open sourcing it, so we would definitely like the community to know when we're ready. Okay, so here's the next part. So in this part, I would like to talk about the rationale for building our AutoSE, like why we would like to invest in this project. So the first question is gonna be, why do we pursue the project at the application level? As we all know that the LLM technology is rapidly evolving, and not just at the model and the infrastructure level, but also in the application layer. In order to stay at the forefront of the innovation, we aim to launch a research project focusing on exploring the core technologies behind LLM applications and AI agents. And also, the other thing is that our S department has always been interested in expanding beyond the traditional S project portfolio and also seek the new growth opportunities. So our project represents a step towards discovering these opportunities. The second question is, why did we choose LLM applications for software engineering? So as you all know that the LLM applications span numerous fields, including healthcare, legal, education, e-commerce, as well as software engineering. However, given our current customer base and expertise, software engineering is the most practical area for us to explore. By focusing on software engineering, we can self-validate functionality in our daily work and also provide fast, actionable feedback. More than that, our S department is keen to leverage LLM technology to enhance R&D productivity. While there's a significant buzz around code agents may somehow replace our engineers, this project will definitely help us critically access how practical and impactful these technologies truly are. And then other than that, we still have some other motivations for building our AutoSE. First of all, we aim to address the specific challenges we face in our own software engineering workflows. We are current tools and process flowchart in optimizing the automation and also the team collaboration. And also by building a robust and the smart system, we would like to improve our development, reduce the repetitive tasks, and also create some solutions that are falling tuned to our unique needs. Other than that, as part of our broader AI initiative, we are committed to exploring the potential of AI agents, the design pattern of that. We would like to discover more ways to revolutionize our software engineering by automating the complicated workflow and also to improve other decision making, and also we can drive the future of AI powered development. Then last but not least, we are always pursuing the opportunities to cooperate and build and share our expertise with our open source community. Then other than that, I would also like to mention that we really hope our AutoSE can truly help the software engineering task and our developer can actually use our AutoSE in their day-to-day work. Since there's a lot of hype in this area, so we definitely do not want to make another half of that. And we really want to deliver practical and also useful features of that. And also from the technical depth perspective, our focus is more on the AI agent layer, and instead of just being a wrapper of that for any existing LLM or any open source agent. Yeah. Okay, so in this part, I want to do a comparison between the GitHub Copilot and as well as our AutoSE. So you guys may ask, what is GitHub Copilot? So GitHub Copilot is an AI-powered coding assistant developed by GitHub in collaboration with OpenAI, which can definitely help you to write code more faster and with less effort, which can also allow you to focus more energy and problem solving and collaboration. And also, the GitHub Copilot is integrated into many popular code editors like Visual Studio Code. So basically, it has a lot of features. And so for example, like you can just get code suggestions as you type in your IDE, and you can also chat with Copilot to ask for help with your code, and you can also ask Copilot to help you with the command line, and you can also generate a description of changes in the pull request. And also, last but not least, you can also create and manage collections of the documentation and also use it as a context for chatting with Copilot. The more important thing that I want to highlight here is that GitHub Copilot often operates in a one-shot manner, which basically means that it can only generate a single complete suggestions based on minimal input from the user. So how does our AutoSE act differently from that? So in comparison with the one-shot service such as the GitHub Copilot, our AutoSE is a more comprehensive agentic AI application workflow system that can support complicated workflow orchestration, planning, and appropriate tooling usage. And other than that, our whole flow process follows the React pattern, and also it can have the human interaction as part of the workflow. And the more important thing is that it can operate iterative interaction rather than the one-shot interaction. So what does this mean? So basically, it can engage in multiple rounds of communication to progressively refine the output, like by processing each round of feedback and also sending back to the model. It can make more improvements step by step, and also it can generate more accurate output. And also, beyond all that, we also have more features and highlights. So let's check it out. Okay, so if you have the command line of AutoSE space dash help, it will just show you the possible command that you can use. So for example, you have the link command, which can help you to link the file. And you also have the def command. That means that if you provide a description, it can just write a patch for you. And for the help command, it can basically give you some suggestions for the comments that you're available to use. Okay. This is the first feature that I would like to introduce. It is called link. So basically, it can just scan a code file or a Git diff to identify potential code problems. Which means it can offer suggestions and potential fix for the problem. So how does this work? We actually have two different modes. As you can see here, I already pasted the last here. So for the file mode, if you do AutoSE space link space your file name, it just can scan your code and then to help you to identify all the potential problems in this file. So I have an example here to show how it works. As I just mentioned, the command line is AutoSE space link space your file name. So in this case, it's the guest city itinerary. This one is a script that will print out the city itinerary based on the user's request, like what specific city that they would like to visit and how many days that they would like to stay. So the potential output of this one could be something like, in the morning, we would like to visit the Eiffel Tower in Paris for day one. And also in the afternoon, we would like to have afternoon tea in Paris for day one. And also in the night, we would like to have a fancy dinner with our family members for day one. So what's the problem in this one? As you can see, the output in the first line, it already identifies the potential risk in this code. Days in the range 1 to days plus 1. And also in the second line is describe the reason of that. So basically in this case, it's saying that there is a risk of days starting from 1, but the risk starts from 0. It should be from 0 to days. So what does this mean? So based on the original code is just iterate from 1 to days plus 1. So the output may be something like morning activities in the specific for day 1 plus 1, which is 2. And also in the afternoon, it may be something like we have the afternoon activities in Paris for day 2, and also in night, we have the night activities in a specific city for day 2 as well. So how did it fix this? You can see here is this change of for loop into for day in range days. So it means that it will just generate the potential output, something like we have the morning activities in a specific city for day 1, and also we have the afternoon activities in a specific city for day 1, and also we have the night activities for a specific city for day 1. Yeah, so this is how it looks like. So let's back to the last slide to talk about the other mode. Other than the file mode, we also have another mode called div mode. And then we have 2 options of that. So if you want to scan a git div to find the potential problems in your code in a specific file, you can do the single file git div mode. So basically you can type something like AutoSE space link space dash div dash mode, and also you need to have your file name in the end. So it will find all the potential problems in this file. And other than that, if you just want to do a project mode, which means if this command is executed in a git manage directory, it will just check all the potential issues in the div in this directory. So in this case, you can just do AutoSE space link space dash div dash mode and make sure you do not have your file name at the end. The output of this mode is very similar to the previous one. And if you want to scan code in the whole directory, you may have more blocks similar to this one, because that will just identify all the potential risks inside the directory that you specify. Let's talk about the second feature, which is comment live. So this means that given a local task descriptor file, it can just help you to generate a local Git patch for the specific task. I also prepared a command line for you guys. So in this case, you can just do AutoSE space div space the file name, and then you need to make sure the file is in so the type of the file should be a YAML file. And also I have a example for this one. So this is how the YAML file looks like. So in the first line, you need to have your repo URL, which means the repo that you're gonna working on. And then in the second line, that's the description, which means you can just write down your description, like how would like to do this task. So for example, in this one, so we're going to create a file which name is utils-go.py, and we would like to implement a find function which will basically go through a folder and also have the specific file. So as you can see in the slide that I already attached a screenshot for that. So this is the output. You can see on the first few lines it is saying that it created a utils-go.py, and also this is the core function in the middle part. So we have a find function which will work through the folder and also find a specific file. And we have the parameter folder, which is the folder that we want to search in. And we have the parameter file name. That means we have the name of the file to find. And also, if we do find the file, we will just return the path of that. If just cannot find it, we will basically return none. The logic of that is also very simple and straightforward. There's the for loop here. So basically, we just look through the folder and we just check if the file name is inside the file. And if it does find it, it will just return a path. And if it just cannot find it, it will just return none. Yeah, so I think this one is very simple and straightforward, and hopefully you guys can get some sense of that. Yeah. Okay, so other than that, I would like to introduce some other key highlights. The first part is the rich setup actions. So basically, we have already added some new actions for the large language model, which can help you to understand the code more efficiently. So basically, we just made it smart. For example, we have already added comments like search class command, and also search method in class, search method in code base, and also search method in file. And also, we are targeting to add the web search as well as the internal wiki search. And other than that, I want to highlight that we also support writing 2 comments in one run, which can definitely save more cost of that. And so I will briefly introduce this one, and I will cover more details of that. So for example, you wanna for example, it wanna search a specific method in file A, and it also wanna search for specific method in file B. So based on the previous design, it may take 2 rounds to finish that, because it needs to search the specific method in file A in one round, and then it may need to search a method in the file B for one round. However, currently we can just support running multiple comments in one round, which basically means that it can finish the searching method in file A as well as searching method in file B in one round, which can just save more cost of that. Yeah, and then I will cover more details about this one later. Yeah, the second part that I want to talk about is the rec support. So basically, it can improve the model ability to retrieve relevant information and also generate more accurate and context-aware response. So basically, we provide the opportunity for users to upload their documents, and then our response is generated by the retrieved relevant information. Okay. Last but not least, I would like to introduce our standing in SWE bench leaderboard. Um, so you guys may curious about like what is the SWE bench? So basically, SWE bench is a benchmarking framework designed to evaluate the performance of the language models in the real world software engineering tasks, specifically resolving GitHub issues. And it can test a system's ability to automatically generate the correct code hash by providing issue description alongside the relevant code base. And also more than that, the system is evaluated based on how well it can propose solutions to the issues. And moreover, models such as GPT-4, Cloud, and also some other models have been tested against this benchmark. And also the SWE bench can definitely assess the real world applicability for language models in software engineering tasks by comparing their outputs to the actual post-PI state of the repository. Other than that, I want to mention that the dataset contains 2,294 pairs of issues and pull requests from 12 popular Python repositories. To evaluate that, we will use the unit test to check if the code was correctly, using the behavior of the code after the pull request as the correct solution. And also, I also have the screenshot ready for you guys to show the SWE bench leaderboard. There are a few fields in this leaderboard. The first field is the name of the project and also the model you use. And then the second one is the proportion of problems successfully solved. And also the third field is the data that is published, and also it attached some corresponding links at the end. So this is our position on that. So our project is named Abundance AutoSE, which is based on the SWE agent, as what I mentioned before, and also we use ChatGPT and also ChatGPT 4.0 Max, and also the proportion of the problems successfully solved by the model out of the entire data set is around like 20.67%. So basically we're at the middle stage of this leaderboard. Okay. Yeah, so other than that, I would like to do a comparison between our AutoSE and SWE agent. So basically, both our AutoSE and SWE agent run the same task, and they all pass the task. And also, as you can see in the output, it just print out the calls and also the API calls and some other metrics in them, so we can just very easily to compare them. So we can see for our AutoSE, we have the total cost of 0.48, and also we have only 8 API calls. Comparing with the SWE agent, it just have more cost than that. It has the cost of 0.92, and also it has 15 API calls. So if you just compare the numbers of that, you can have the conclusion that we definitely have lower number of total cost as well as the API cost. So which can prove that we definitely save more cost. So why is that case? I would love to explain more details of that. As I mentioned before, we can just support running multi-commands in one run, which can help to save the cost. So I have a very simple example of this one. So for example, you need to search for so for example, you need to search for the 2 different classes in the code base. And then based on the previous design, if you want to search class for these 2, it definitely takes you 2 rounds to do that. However, in our case, it can just search the 2 class in 1 round. So you can see the screenshot right here. So and other than that, it can just have the output. So for example, you can see the first one is in line 9, and also the second one is in the line 19. So it can also return the 2 outputs in 1 run. So basically, it can just also return the 2 outputs in 1 run as well. So it can show that we can definitely save more cost on that. Yeah. So I feel like after showing this example, you guys may have some ideas about like why we can save more cost than the SW agent. Yeah. So yeah, I think that's pretty much I have for today, and thank you so much. Yeah.
I'm checking your agenda. Here for 2 minutes. We have 2 minutes
Yeah,
for
we
Q&A.
have 2 minutes. So if you guys have any comments or any questions so far?
Yeah, so are there any like use cases or anybody outside of guidance?
So we are still targeting our focus on this, so we're still working on that. So probably later we can have a.
Okay, thank you so much.